In this video, I'd like to give some examples of how we will use the general binomial expansion in the previous video, and in particular, I'd like to find some binomial expansions of these expressions circled in green, and we're also going to state the values of x for which they are valid. So if we take the first one, we have the square root of 1 plus 3x. And to use our general binomial expansion, which I've put in this blue box, we need it to be in the form 1 plus x to the power of n. Well, we can do that by writing this as 1 plus 3x to the half, so we know that n equals a half. But let's be careful because one of these has an x and this one has a 3x. So instead of x in our general binomial expansion, we're going to use 3x. So what does this then become? So we get 1 plus n lots of x, so 1 half, and instead of x we have 3x. And then we have n and then n minus 1, so a half times a half minus 1 is minus a half, divided by 2 factorial, multiplied by 3x in brackets all squared. And in the question it asks for the first 4 terms, so the next one is going to be n is a half, n minus 1 is minus a half, and notice here I forgot the half in this second term, but I forgot the negative in this second term, but I've just put that in. And then n minus 2 is negative 3 halves, all divided by 3 factorial, multiplied by 3x all cubed, and then adding on those remaining terms. So let's now just go ahead and simplify that. Well, that becomes 1 plus 3 over 2 x. And then here we're going to have one negative sign, so it's going to be negative. A half times a half is a quarter. Divided by 2 factorial is multiplied by a half, so it's actually an eighth. And then we're going to have 1/8 of 3x all squared, so it's 1/8 of 9x squared, or 9/8 of x squared. Okay, here we're going to get a negative times a negative, so this is going to be positive, and then we have a half times a half times 3 halves times by 1 over 3 factorial, so that's 1 over 3 times 2 times 3 cubed x cubed. And I'm going to try and cancel some factors before I work that out. So we have 1 plus 3 over 2 x minus 9 over 8 x squared. And then we can cancel a factor of 3 here. So what do we get? We get 2 to the power of 4, which is 16 on our denominator. And we have 3 cubed, which is 27 on our numerator. So we have 27/16 of x cubed. And there are our first 4 terms. Well, when is this valid? Well, our general binomial expansion is valid when x is between minus 1 and 1. So this is valid when 3x is between minus 1 and 1, which is equivalent to saying x is between negative a third and a third. In the second example, we're asked to find the binomial expansion of 1 plus x over 2 to the minus 3 over 2. And this is already in the form we want, so that we have n is equal to minus 3 over 2. But instead of x, we have x over 2. So we're going to replace all of our x's with x over 2's. So what do we get here? We get 1 plus nx, so minus 3 over 2 lots of x over 2. Then our next term is going to be n, so minus 3 over 2, n minus 1 is minus 5 over 2 factorial, lots of x over 2 all squared, and then add n, so minus 3 over 2, n minus 1 minus 5 over 2, n minus 2 minus 7 over 2 over 3 factorial lots of x cubed, but this isn't x cubed, we're using x over 2 here, x over 2 cubed plus the remaining terms. So now it's just a matter of simplifying this expression. So we get 1, and this is going to be minus 3 over 4 lots of x. Here we are going to get a negative times a negative. 3 times 5 is 15. So we have positive 15, and then we're going to have 2 times 2 times 2 squared times by 2 factorial. So actually 2 to the power of 5. 2 to the power of 5 is 32. So 15 over 32 lots of x squared. Here we are going to get a negative times a negative times a negative, which is negative. We have 3 over 2 times 5 over 2 times 7 over 2 times by 1 over 3 factorial, which is 1 over 3 times 2, times by x over 2 cubed. So that is going to be 1 over 2 cubed x cubed. And now we can cancel some factors. Well, the only factor that cancels is actually just this 3 here. But it does make our life a bit easier. So if we simplify this, we get 1 minus 3/4 of x plus 15/32 of x squared minus 35 over 2 to the power of 7, which is 128 x cubed. And we're asked, when is this valid? Well, our general binomial expansion is valid when x is between -1 and 1. So this is valid when x over 2 is between -1 and 1, which is equivalent to saying x is between -2 and 2. And in the final example, we are asked to find the binomial expansion of 1 over the cube root of 1 minus x. So firstly, we need to remember we need to get it looking a bit like 1 plus x to the power of n. Well, we can do this by realising this is 1 over 1 minus x to the power of a third, which is 1 minus x to the power of minus a third. So we have n being equal to -a third. And what we need to be very, very careful of here is in our general binomial expansion result, we have a plus x here. But here we have a negative x. So if all of our x's need to be replaced by a negative x in our binomial expansion. So let's do that. What do we get? We get equals to 1 and then plus -a third lots of negative x plus -a third. -a third minus 1 is -4/3 over 2 factorial. And then we have negative x all squared. And then we have -a third, -4/3, -7/3, because that is -a third subtract 2, over 3 factorial multiplied by -x all cubed, plus these remaining terms that we're not asked to calculate. Well, now let's just simplify this. So this is 1 plus +a third lots of x. This one is also going to be positive because we have 4 negatives being multiplied here. We have 1 times 4, so we have a third times 4/3 times 1 over 2 factorial, so times a half, lots of x squared, and we'll simplify that later. And then we have a third, and notice here we're going to have 6 negative signs being multiplied together, so this definitely is positive. So we have a third times 4/3 times 7/3 times 1 over 3 factorial, which is 1 over 3 times 2, and then times by x cubed. And that's not negative x cubed here, because I've used the fact that we are multiplying together 6 negatives, so that's going to be positive. Well, cancelling some factors, what do we get here? Well, we get 1 plus a third x. Here we have a factor of 2 that cancels. So this is going to be plus 2 over 9x squared. And then here we have a factor of 2 that cancels. So we have 14 over 81 x cubed plus our remaining terms. And we know our general binomial expansion is valid when x is between -1 and 1. So this is valid when negative x is between -1 and 1, which is just equivalent to saying x is between -1 and 1.